Hi, my name is Prabodhadinath Manamperi. My registration number is MS21901676, and I'm going to present my wireless network technology assignment presentation. Before I proceed, first I would like to thank Mr. Tilak De Silva, the lecturer of wireless network technology module at the SLIT, for his guidance and immense support to achieve this level of knowledge about the module and create this presentation. Thank you, sir. What is a protocol? In networking, a protocol is a set of rules for formatting and processing data. Network protocols are like a common language for computers. The computers within a network may use vastly different software and hardware. However, the use of protocol enables them to communicate with each other regardless. Importance of standards. Basically, standards determine how accurately the data information can be transmitted between two hosts. These are few standard bodies: Telecommunication Industry Association, TIA, European Telecommunication Standard Institute, ETSI, TTA, CWTS, TEC, blah blah blah. IEEE and ETSI. IEEE and ETSI comes together to define common standards to promote, directly or indirectly, international standardization with the aim of contributing to the establishment of global standards. As wireless communication is a method of transmitting data from one point to another without using wires, cable, or any physical medium, the better known specification for Wi-Fi is 802.1111. 802.11. Any further update related to these standards comes under 802.11, 11A, 11B, 11D, etc. ISO-OSI 7 layers. The OSI model has 7 layers, which includes physical layer, data link layer, network layer, transport layer, and session layer, presentation layer, application layer. Generally, each layer has its own generic functionality to fit into this network stack. Application layer defines data where the presentation layer does the formatting of the data, which includes data formats like images and videos files. Session layer tracks the application processes, and it generally includes remote procedure calls and service requests. Transport layer, network layer, data link layer, and physical layer can be described as lower layers, where application layer, presentation layer, and session layer can be described as upper layers. Basically, what lower layer does is break down the data into manageable chunks and send it through by adding destination addresses, headers, and trailers in each layer until the physical layer, which ultimately sends the data through a network cable or wireless medium to the remote host. Once the host receives data, then the process is reversed. Just like the OSI model, TCP/IP model uses several layers to transmit data. Also, there are two types of TCP/IP models, which described as original and current versions. The original version has 4 layers, where the revised version has 5 layers. The revised model splits the network layer in original version into 2 separate layers, as data link layer and physical layer, which makes a layers altogether 5. The good thing about the current version is it aligns perfectly with the OSI model. Application layer, presentation layer, and session layer that are in the OSI model defined as a single application layer in the TCP/IP model, which basically handles application and processes like HTTP for web browsing, SMTP for mail delivery, and FTP for file transfer. These application creates processes which listen on particular ports That's the main job of the transport layer, which uses the protocol TCP and UDP. In the revised current model, the network layer, data link layer, and physical layer, which also can be described as data transfer layers, focuses on getting the data from one host to another. The network layer uses the Internet Protocol or IP. The physical and data link layer moves the data from one device to device across switches, access point, Wi-Fi, routers, etc. Ethernet is a very common protocol used here. In the old days where we had original version of TCP/IP, it didn't have any different physical connection options like Ethernet, Wi-Fi, fiber optic as we have today, which is the most common reason why the breakdown the network layer into two separate layers that includes data link layer and physical layer in the reverse model. TCP/IP reliability is so high is the reason why it has become the most widely used network protocol. Analog signal. An analog signal is a continuous signal in which one time varying quantity, such as voltage, pressure, etc., represent another time-based variable. In other words, one variable is an analog of the other. The result is that analog system allows for a theoretically infinite number of values to be represented. It can achieve any values with the parameters governing the system. Basically, the signal is electromagnetic current that varies with time and used for carrying data from one device to another. These are some widely varied applications where analog signal is used: audio recording and reproduction, live sound amplification devices, older video signal transmission technologies, VGS, video etc., radio signals, television broadcast signals. Digital signal must have a finite number set of possible values like ones and zeros. The number of values is that in the set can be anywhere between 2 and very large number. It's like finite number. Most commonly digital signals will be one of two values, like either 0 or 5. Timing graph of this signal looks like square waves, where the analog signals looks like scribble. Amplitude, frequency, and phase of a sinusoidal signal. Amplitude, also known as peak amplitude. The peak amplitude of signal is absolute value of its highest intensity proportional to the energy it carries. For electric signal, peak amplitude is normally measured in volts. Period and frequency. Period refers to the amount of time in seconds. A signal needs to complete one cycle. Frequency refers to the number of periods in once. Note that period and frequency are just one characteristic defined in two ways. Period is the inverse of frequency and frequency is the inverse of period. Phase. Basically, position of the signal can shift to a forward or backward. That is called phase. The bandwidth of composite signal is the difference between the highest and the lowest frequencies contained in that signal. Transmission impairment, attenuation. Attenuation means the loss of energy. When a signal, simple or composite, travels through a medium, it loses some of its energy in overcoming the resistance of the medium. That is why wire carrying electrical signal gets warm, if not hot, after a while. Some of the electrical energy in the signal is converted to heat to compensate for this loss. Amplifiers are used to amplify the signal. Distortion. Distortion means that the signal changes its form or shape. Distortion can occur in a composite signal made of different frequencies. Each signal component has its own propagation speed through a medium and therefore its own delay in arriving at the final destination. Different in delay means greater difference in pace. If the delay is not exactly the same as the period duration, in other words, signal component at the receiver have phases different from what they had at the center. The shape of the composite signal is therefore not the same. Noise, the other most important part of transmission impairment. Noise is another cause of impairment. Several types of noises such as thermal noise, induced noise, crosstalk and impulse noise may corrupt the signal. Thermal noise is the random motion of electrons in a wire which creates an extra signal not originally sent by a transmitter. Induced noise comes from sources such as motors and appliances. These devices act as a sending antenna and the transmission medium acts as the receiving antenna. Latency of signal. It's basically the combination of propagation time, transmission time, queuing time and processing delay. PCM processors. PCM encoder has 3 processors. The analog signal is sampled, the sample signal is quantified. The quantified values are encoded as streams of bits. Low rate encoding methods, encoding techniques, analog data to analog signal, analog data to digital signals, digital analog signal, digital data to digital signals. Modulation types, QPSK, 64QAM. Multiplexing types, frequency division multiplexing, TDM, OFDM, frequency division multiple access, time division multiple access. In a network, we need to send data from one host to another. Sender sends the signal as bits like ones and zeros. This is called a data word. When the receiver gets the data, they might corrupt it during the transmit and the receiver might reject it. To avoid this, few extra bits are added to the original bits before sending. This new data set is called code word. Usually when the sender transmits data to another host, redundant bits are added as code words. The receiver then has a set of code words to check incoming data with the corresponding code word. If the code is not matching, it is as an error, like error detection. The basic points here is the receiver has a list of valid codes. The original code word has changed to an invalid code. The two methods are used for error correction, which is forward error correction, backward error correction. Cyclic code is the block coding method and also help error correction and error detection. If given set of code words follow the two properties like property of linearity, shifting property, and gives another word that belongs to the same code word. It is called cycle code. Transmit buffer is the area where the sender keeps its data as frames. Usually it is a memory. And at the receiver end, we call it a receiver buffer. We can increase or decrease the transmit or receive buffer based on the outgoing network traffic. If the sender transmits data at high rate and the receiver cannot get the data at the same rate, there might be a network traffic carrier at the receiver end, and data might get lost. A flow control will give the ability to receiver's end to control the transmission speed so that both senders and receiver can communicate about the transmission and buffer speed, and they can adjust accordingly. CSMA protocol basically used for wireless network. 3 types of strategies: interframe space, contention window, acknowledgement. MAC layer. The media access layer control layer is one of the 2 sublayers that makes up the data link layer of the OSI module. The MAC layer is responsible for moving data packs to and from one net interface card to another across shared channel. The MAC sub-layer uses MAC protocol to ensure that signals sent from different stations across the same channels don't collide. Data link layer is basically divided into 2 layers, 2 parts actually, which has logical link control layers and media access control layer like LLC and MAC. LLC looks after the basic function of the data link layer, such as establishing and the termination of the link, error control and flow control, and overall managing the channel. LLC layer frame format basically uses 802.2. IEEE 802.11 architecture components, stations, basic service sets, extended service sets, distribution sets. We call it as STA, BSS, ESS, and ES. IEEE 802.11 MAC layers, sub-layer frames include a frame control, duration, address field, sequence, data, and check sequences. So that's basically about assignment 1 presentation. Thank you.